Okay, and here we go again. I'm going to do this one. This is assessment number 12. So you're going to read this right here, and you're going to see what it says. So number 1, what's going on? It is moving at a constant speed. Okay, and it's going forward. I'm just going to put abbreviations. The second one is moving. It's not moving at all. It's at a stop because it's on the 0 line. Remember, this is the 0 line. And then it's going backwards, constant speed. Okay, so constant speed back. Yeah, that's what that is. All right, next, this one is where we're at. All right, so it says calculate the net force, tell the direction the block A is moving. Okay, so, and I'm going to use a different color. So you've got 2n and 2n. 2n minus 2n equals 0n, so these guys are canceled out. 3 plus 1 equals 4 newtons, and 4 minus 6 equals 2 newtons, and it would be going up. And why is it going up? Because the 6 is bigger than the 4. That's why. All right, next. All right, so it says, draw a diagram for the following. A student runs to the right down the hall. No running in the hall, first of all. So I'm drawing, here's my dot, or shall I say, my student. And they are running. This is an applied force because they are actually running. All right, so, and if they didn't fall through the ground, if they did not fall through the ground, they're running on the ground, so that means gravity is working. All right, but they didn't fall through the ground, so that also means that normal force is also working. Okay, and anytime you see applied force, there's always going to be friction. So friction is like the hater of applied force. Anytime applied force wants to go this direction, friction wants to go that direction. Kind of like a hater, always trying to pull you down. So you got friction, and then you also have air resistance. Okay? And that's about it. Notice that the applied force is much bigger. So, and it's bigger because the person is actually accelerating in a certain direction. And these guys are too tiny and puny to do anything. Okay, so they're not really, they're slowing them down, but they, if it wasn't for air resistance and friction, then the person would never be able to stop. So, there you go. Next. Okay, and now it says Newton's second law. How heavy is the block A from above if it is accelerating at 5 meters per second? This may or may not be the formula you need. All right. So if we remember from earlier, the answer to this problem was 2 newtons. Okay, so now let's go ahead and plug it in. So you got F equals ma. What is it that we're asking? So we know what the acceleration is, and we have the force. Okay, and so we know what all those are, and this is 5 meters per second. Oh my gosh. Second square. All right, what is our mass is what it's asking, because it says how heavy. So we're going to use this formula, m equals F over A. So let's plug stuff in. Force is 2 newtons. Acceleration is 5 meters per second squared. What is our answer? So 2 divided by 5 is going to be 0.40. And what are our units? Well, it does say mass, and mass is always written in kilograms. So that is our answer. Bam. Done.